Welcome to Polygons, Perimeter, and Area. First, to identify polygons. A polygon is a closed figure that lies on a plane with the following properties. First, it is formed by three or more line segments called sides, and these cannot be curved. Second, each side intersects exactly two sides, one at each endpoint, so that no two sides are collinear. A vertex each endpoint of a side of a polygon. With vertex, we have the plural of vertex as vertices, and a polygon can be named by the listing of the vertices in consecutive order. So here, this is polygon A, B, C, D, E. Couple of definitions. You have convex. It's a polygon in which no line contains a side of the polygon that contains a point in the interior of the polygon. So here is a convex shape. The idea is that every angle, every vertex is outside of the polygon. There isn't anything inside in the interior. There are no angles greater than 180 in a convex shape. In a concave shape, there's at least one angle that is greater than 180, and it's a polygon that's not convex. So here it caves in, so this is concave. Couple of examples for this, identifying polygons. The first one is not a polygon because it actually has a side length that's inside of the shape, so it's not a polygon. B is a polygon, and it's a convex because it has no angle greater than 180. C is not a polygon because it has a curved edge. And D is a concave polygon because there are four angles greater than 180. Okay. To classify a polygon, you need to know some of the names. So we have number of sides and then the type of polygon. 3 is a triangle, 4 is a quadrilateral, 5 is a pentagon, 6 is a hexagon, 7 is heptagon, 8 is octagon, 9 is nonagon, 10 is decagon, 12 is dodecagon. And if you don't know anything after this, you can use n, or which is a number. It's the number of sides. So you can have a 13agon, a 25gon, but the idea is that we put the number before the word gon. So let's look at some regular polygons. The first type of regular polygon is an equilateral polygon. It is a polygon that has all equal sides. Same with angle. You have the equiangular polygon. It has all equal angles, and if it's both equilateral and equiangular, it's therefore regular. So a regular polygon is a convex polygon that is both equilateral and equiangular. So here, this pentagon is all sides are congruent, therefore it's equilateral. All angles are congruent, therefore it's equiangular. And since it's both equilateral and equiangular, it is therefore regular. So some examples. A is a regular hexagon. B is a quadrilateral. There are no, all four angles are not congruent, all four sides are not congruent, so this is just a quadrilateral. And then C, it is equilateral, but it's not equiangular. Because it's concave. So this is just equilateral. It's a dodecagon because it has 12 sides. Your tables in biology class are regular hexagons. Regular meaning it's equilateral and equiangular. If one side length is 3x plus 6 and the other is 4x minus 2, we know that the sides are congruent, therefore we set the lengths equal, and we can solve for x. Subtract 3x from both sides and we get x equals 8. And it said find the length of one side, so we're going to substitute 8 into either 3x plus 6 or 4x minus 2. And we get 30 inches. Going on to perimeter and area. Perimeter is the distance around a figure. Circumference is the distance around a circle. And area is the amount of surface covered by a figure. Perimeter and circumference is one-dimensional. It's measured in units of length, such as meters or feet. Area is two-dimensional, and it is measured in square units, such as square meters or square feet. The formulas for perimeter, area, and circumference. Square, perimeter is 4s, area is s squared. Rectangle, it's 2l plus 2w. Area is L times W, length times width. Triangle is, a perimeter is just A plus B plus C, you just add up all the sides. Area is 1/2 base times height. And on a circle, circumference is pi times diameter, or 2 pi times radius. And the area is pi times radius squared. So to see these examples, the first one's a rectangle, so the perimeter is 14 times 2 plus 9 times 2, which gives us 46 feet. And the area is 14 times 9, which is 126 square feet. The second example is perimeter. You just add up all sides, 5 plus 12 plus 13, and we get 30. Area is 1/2 times the base, which is 12, times the height, which is 5, and we get 30 square inches. And then for a circle, this is circumference, which is 2 times radius times pi. So this is 30 pi, or 94.2. And then we get 15 squared times pi, so 225 pi, or 706 square yards. Right, and sometimes you might have to go backwards. So here, this is the area is 55.5. This is a triangle. We're looking for the base. It's 1/2 base times height. The height is 9.25, and it's equal to 55.5. So we fill in all of our information. There's two ways you can solve this. First, you can do 1/2 times 9.25. That would be fine. Or the way I would like to do it is actually get rid of the 1/2 by multiplying by 2. So here we get 111 equals b times 9.25. And we're going to divide by 9.25 to get b by itself. So our base is 12 meters. All right, that is polygons, perimeter, and area. Good luck on the practice.